Let's solve some momentum problems. We'll go through 4 questions in this video. How do we calculate the final velocity of an object after a collision? Keep watching to find out. For our first question, we have a 1500 kg car which has a velocity of 36 meters per second. How much momentum does it have in kilogram meters per second? The first variable we have been given is the mass, so m equals 1500 kilograms. The second variable is velocity, so v equals 36 meters per second. We want to find momentum. Momentum has the symbol lowercase p, so p equals question mark in kilogram meters per second. Momentum is equal to mass times velocity, so p equals mv. Every moving object has momentum. Heavier objects will have more momentum than a lighter object, and objects going at a higher velocity will have more momentum. Let's substitute our values into the equation. P equals 1500 times 36. Let's put that into the calculator. 1500 times 36. That gives us an answer of 54,000 kilogram meters per second. Question 2. A 2 kilogram mass is moving with a velocity of 3 meters per second when it collides with and sticks to a 4 kilogram mass initially at rest. What is the speed of the combined mass after the collision in meters per second? There are 2 objects in this question, so let's say the variables relating to the first object has the subscript 1. m1 equals 2 kilograms and v1 initial equals 3 meters per second. The variables relating to the second object has the subscript 2. m2 equals 4 kilograms and v2 initial equals 0 meters per second. We have been asked to find the speed of the combined mass after the collision. So we can say v1 and 2 final equals question mark in meters per second. The principle that we need to understand is that momentum is always conserved in a collision. So the total initial momentum Pi will be equal to the total final momentum Pf after a collision. We can write this as m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final, assuming there are 2 objects. In this example, this is a sticky collision where the 2 objects stick together, so we can rewrite it as m1 v1 initial plus m2 v2 initial equals m1 and 2 times v1 and 2 final. Because the initial velocity of the 4 kilogram mass is 0, we can just get rid of m2 v2 initial. m1 and 2 will be the combined mass, 2 plus 4, so m1 and 2 equals 6 kilograms. We want the final velocity, so we will rearrange for v1 and 2f. Just divide both sides by m1 and 2 to get v1 and 2 final on its own. Let's substitute our values into the equation. v1 and 2 final equals 2 times 3 divided by 6. Let's put this into the calculator. Fraction button, 2 times 3, then arrow down, then 6. That gives us an answer of 1.0 meters per second. Question 3. 2 birds collide and stick together in midair. The first bird was flying east at 10 meters per second, while the second bird was flying west at 8.0 meters per second. The first bird has a mass of 2.0 kilograms, while the second bird has a mass of 3.0 kilograms. What is the speed of the 2 birds together immediately after the collision in meters per second? Again, there are 2 objects in this question, so bird 1 will have the following variables. Mass m1 equals 2.0 kilograms and initial velocity v1 initial equals 10 meters per second. The second bird will have mass m2 equals 3.0 kilograms and an initial velocity v2 initial, which equals negative 8.0 meters per second. The initial velocity of the second bird is negative because it is in the opposite direction to the initial velocity of the first bird. We can say either one of these two birds have a negative velocity, but what's important is that one of them has the opposite sign. The two birds form one mass after the collision, so we will say m1 and 2 equals 2.0 plus 3.0, which equals 5.0 kilograms. We want to find the speed of the two birds together, so v1 and 2f equals question mark in meters per second. We can use the same equation as the last problem. Initial momentum equals final momentum, and then we just need to rearrange for v1 and 2f. So if we rearrange it for v1 and 2f, then v1 and 2f equals m1 v1 initial plus m2 v2 initial divided by m1 and 2. If we substitute the values, then it becomes 2 times 10 plus 3 times 8 over 5. Let's put this into the calculator. Press the fraction button, then 2 times 10 plus 3 times negative 8, then arrow right or down to get to the denominator, and then enter 5. That gives us an answer of negative 0.8 meters per second. It is negative, the two birds together will be going in the direction of west. The answer will be 0.8 because we just wanted the speed, which is a scalar quantity with no direction. Question 4. A 30 kilogram boy on a skateboard is riding at 8.0 meters per second when he collides into a girl on roller skates who is stationary. If they stick together after the collision and have a velocity of 3.0 meters per second, then what is the girl's mass in kilograms? Let's say the boy has mass m1 and it's equal to 30 kilograms, and his initial velocity v1 initial is equal to 8.0 meters per second. The girl's initial velocity v2 initial is equal to 0 meters per second, and we've also been told that the final velocity of the two together is 3.0 meters per second. We want to find the girl's mass, so m2 equals question mark in kilograms. We will use the same momentum equation. Initial momentum is equal to final momentum. So we have m1 v1 initial plus m2 v2 initial equals m1 and 2 times v1 and 2f. Because the initial velocity of the girl, v2i, was 0, we can get rid of m2 v2 initial. We can now rearrange for m1 and 2 by dividing both sides by v1 and 2f. So now we have m1 and 2 equals m1 v1 initial over v1 and 2f. Let's put the numbers in. So 30 times 8 over 3. If we put this into the calculator, fraction button, then 30 times 8, arrow down, then 3, we get an answer of 80 kilograms. Now that we have the mass of the boy and the girl combined, we can subtract the boy's mass from the total mass to find the girl's mass. 80 minus 30 is equal to 50 kilograms, and that is our answer. That's it for essential momentum. In the advanced momentum section, I go over elastic collisions where the two objects don't stick together and how to use simultaneous equations to solve for final velocity. Try to solve these questions on your own, and if you get stuck, you can refer back to this video. In the next video, we'll go through torque problems. See you there.